Because why? We learned a different method from yesterday concepts. Okay. So looking at question 8, if you're limited to what we learned previously under chapter 1.1, okay, what we did was that using our 4x squared minus 12x plus 10, we know that the coefficient of x squared being positive, it will give us a U-shaped curve, which is a minimum point. Okay, such that if I do my completing the square, 10 over 4. 10 over 4 is 5 over 3. And someone have me calculate minus 9 over 4 plus 5 over 2 is what? Half. Minus 9 over 4. Okay, someone count minus 9 over 4 plus 5 over 2 is already 1 over 4, right? Okay. Okay, so upon completing a square, this is what we get. So because this question has a minimum point, okay, and we see that the minimum value is 1, which is more than 0. Okay, that's why your 4x squared minus 12x plus 10 is positive. Okay, so this is based on what we learned in chapter 1.1, where we want to use the minimum value, okay, to justify that it is a positive function. Alright, now what if we want to use what we learned yesterday regarding discriminant? Okay, how can we use discriminant to go about explaining this question? Okay, this question is no different from saying to explain why is it that this function is always positive for all real values of x. Yes,
I was such that I take x minus 1.5 squared, then I times 4 plus 1.
Okay, oh, sorry, I forgot that. Wait. My bad. But that because it will never intersect with the x-axis. Because always positive means that there's no intersection with the x-axis, no x-intercept, so your discriminant must be less than 0. Furthermore, we also learned that it must be of a certain shape. It must be of this shape, then it can be always sitting above the x-axis itself. you can never have a set face shape, okay, that is sitting above the x-axis, because we know that our graph continues. Okay, that was what we clarified yesterday. Alright, so there are two conditions to it. Then it must be of this shape, and that means that your coefficient of x squared must be more than 0. So to answer this question in an alternative manner, okay, what we will do is we find the discriminant. 144 minus 160, that is negative 16. See? Okay, and this is less than 0. And then our coefficient of x squared is positive, so we can say that since discriminant less than 0 and coefficient of x squared, okay, equals to 4, which is more than 0. So these two conditions are satisfied. We can say that 4x squared minus 12x plus 10 is positive. Okay, so what I'm trying to do here is I'm showing you something that we can solve in just, I don't know, 3 lines, 4 lines, if you want to count it that way. Okay, in comparison to what we did in chapter 1.1, which was definitely more tedious as a task. Okay, so there are always many ways to go about solving things. Alright, and this is an alternative based on what we learned from chapter 1.2. Okay, and I think that this is worthy to be copying down as a form of correction to your homework. Remind yourself about alternative ways as well. Okay? Okay, and then we can say that there are two distinct real roots. Come in. Okay, and then discriminant equals to 0. How many x-intercepts are there? 1, okay?
Yes.
And we say that there are actually two real and repeated roots. Right? And then your discriminant less than 0 imply there are how many x-intercepts? 0. We just discussed over that. And then we also talked about different kind of cases where we have always positive or always negative. Okay? So when we say always positive, we think about your discriminant being less than 0 and it must be a happy face, a minimum point, so A must be more than 0. And then if we say always negative, it will be discriminant less than 0 still, and your A must be less than 0. Okay? So it is not about the word positive or negative that affects the inequality sign over here. So it's not that W positive, that means W is more than 0. It is about the idea that we're looking at, the shape of the graph. Okay, that we're looking at the graph trying to be below or above the x-axis. Then we explore the x-intercepts that leads us to this conclusion itself. Okay? Then also we encountered the idea of at least one x-intercept. more than or equals to 0. So these were the things that we explored yesterday. Okay, in an even shorter summary, yesterday I did more words than that. Alright? I want us to reinforce the idea, okay, by taking a look at perhaps exercise 1.2, question 9. Find the range of values of A for which the graph lying completely above the x-axis. Just looking at part A, and then I want to do a side-by-side comparison to question 13, part I. Okay, so I intentionally write these two questions side by side, okay, for us to be very clear in knowing what the questions want. Okay, so in question 9, it says find the range of values of K for which the graph lies completely above the x-axis. Okay, so what are you supposed to find? What are you supposed to find? We want to find, just taking words from the question itself. Find the range of values, okay, right? Okay, so when I was in JC, my teacher always write this, want to find, okay, range of values. Okay, I'm not writing a vulgarity, okay? It is your brain, it thinks otherwise, not my fault. Okay? So, question 9a, we want to find range of values of A. Whereas question 13, okay? We want to find, okay? In this case, what do we want to find? Okay, maybe I just restructure this question a little bit first before I talk more about it. If the question is phrased this way, okay, prove that this is this for all the values of x. Okay, so what are we trying to find? Or what are we trying to justify? All real values of x are positive. That is never possible. Because real values are negative numbers to positive numbers. So you can never justify that all real values of x are positive. So you want to prove this, right? So whatever you prove must come at the end. Okay, so what is the qualifier, what's the justifier before this statement? What is the evidence that we must show? Yes, we want to show that this thing is greater than 0, and how do we do that? What are the evidences that we need to provide? The question is not asking you to find range of values of x, right? Just by comparing that question and this question. This question isn't asking us for range of values of x, right? This is to prove this is positive. Okay? Yes, Shannon. Yes, okay, so it is to find that the discriminant is less than 0 and your A is more than 0, because this tells us that we're trying to prove that it is always positive, so we need to justify it by this statement. So this is the evidence that we need to show, and that is what we need to find. Okay, so there are the two differences in these two questions. Hope that you can see in this manner and notice the differences. Why I want to emphasize on this difference? Because very often, okay, as you practice more, you get so fixated on the way of doing, okay, that you ignore the question itself and then you do things on your own, okay, not knowing what you're supposed to do. So we must have clarity over what we're supposed to do. Okay, this one is to ask you to find the range of values, okay? Whereas you're supposed to be doing here, proof that this is positive. Okay, yes, teacher.
But why is it important? Like
Why is it what? Sorry.
why is like the question contain always positive? Like why they
Because this interpretation, how do you read it in English? So it's about how you read it, right? Okay, it is saying that we want to prove that this quadratic function is always positive. Do you not agree that more than 0 means always positive? Yeah. So that's why we need to be very comfortable with how is it that inequality is being switched to wording itself. Okay? So hence reading the question is very important. You cannot always see it as more than 0. Okay, what does more than 0 mean? It actually means always positive. You understand? Okay? So you must read it in English way. Right? So now question 9. We do question 9a first. We want to find the range of values, okay? So what are the given information? The given information is that it lies completely above the x-axis. Okay, so with that given information, alright, what we can conclude is that your discriminant must be less than 0. Because that's a given. Okay, it's not what we want to find out, this is a given information. So, based on the quadratic function that we have, okay, the discriminant will then be 2 square minus 4, 1, c, k plus 1. Okay, x turns out to be this. Right? And that simplifies to negative 4k. So because this is given to us, we can use this. Okay, negative 4k less than 0. And hence, k is less than 0. Okay? Right? So, we don't need to go and consider your a is more than 0 as well. By right, it should be at a more than 0 lah. Okay, but we know that this is verified already due to coefficient of x squared being positive already. Okay, yes, Alex. Yes. Okay, questions? Yeah.
So the k is more than 0 is just
The range, so that is a range, right? An interval, an inequality is a range. Okay. Next, we look at question 13. Okay, we want to find that discriminant is less than 0. Okay, wait. Okay, we want to find that the discriminant is less than 0. Okay, but before that, let me change back the question. Okay, the original question was more than negative 4. Okay, so this was the original question. Alright, but you saw how I did it just now, whereby we need to be able to interpret this inequality, okay, into an alternative, which is this, which reads to us as the quadratic function being always positive. Okay? So that is how we interpret this itself. Okay? So it's just a shifting of negative 4 over time. Right? So don't get distracted by not having a 0 on the right side. Okay, we can create that by shifting your negative 4 over. So now we want to find that your discriminant is less than 0. So in this case, the function that we're referring to, I'll use fx to name the function. Okay, our discriminant is actually b squared minus 4ac. In this case, that is 4 minus 16 times 232. And that is 28. So we can find that the discriminant is a value, negative 28. Okay, so we have found that it is negative and less than 0. Okay, so to prove that, we will say that since discriminant less than 0 and coefficient of x squared, okay, is more than 0 because it is equals to 2, then 2x squared plus 2x more than negative 4 for all real values of x. Okay, I'll need you to think about this first before I go on to the next question.
I don't understand why 2 square minus 4 is less than 0. And it is
For this one, I calculated it out. As in, why is it that we want to find this? Because the question says to prove this inequality. Okay? But you cannot see as just proving an inequality. We need to see the alternative meaning to it. Okay? The alternative meaning to this inequality is that I can shift this negative 4 over to the left, and this reads differently to us already. Because this is a quadratic function, telling us that this quadratic function is always more than 0, in other words, always positive. So that is the alternative interpretation to this statement itself. I change I shift it. Okay, of course you can do it another way. Are we done with this one? Are we done with this side? Okay, I erase
Then why don't we use like equal sign instead of parentheses? So that's the
equal sign to where here?
So
This one.
what do you know is equal sign?
Because based on this, we read it as this statement. And we agreed that when we say a quadratic function is always positive, that means that it never cuts the x-intercept. So your discriminant is less than 0. And that is only possible when you have a smiley face graph, minimum point. So your A must be more than 0. Yes. You get it? Think about it. Anybody else has maybe anybody else also same confused by have the same confusion as Jaden? No? Yes, teacher.
Is it possible to do it for like the other way?
That means instead of shifting -4 here, everything else shift the other side. Is that what you say? Or what you mean by the other way?
Like for just now the range of values, is it the same?
No, but we just not accepted that this one was the thing that we want to find is the range of values of k. There was an unknown for us. In this case, there's no unknown for us to find. K was a constant just now that we had to find. This one, this expression, there's no unknown. S is a variable, which is not meant to be found because it's all real values in x. Okay, hang on.
Is it because you know it must always be positive? That's why like.
Sorry, can you repeat that?
Is it like always? Is it because you know like it's always positive? So then you need to find it.
So that one?
So like the previous one, there's a unknown, but this one you can find something.
I don't want to draw that conclusion because I can put unknown inside here. Yeah. Then your process still remains the same. It is not about whether the unknown exists or not. Yeah. It is about what the question wants you to find. And that is the part that is critical. Yeah, we must be very clear about what the question wants us to find. just now from the question statement itself, it was very clear. It says find the range of values of x. Okay? While for this one, it is to prove that this is going to happen. And how are we going to prove something? Okay, we need to give the correct evidence. Okay, and in this case, the correct evidence is this discriminant and a more than 0. Okay? Understand? Okay? So it requires a little bit of thinking. You sit through it, if you think about it, the wording, okay, I hope you will get it. Okay? We will see more questions and you understand. Alright? So, Jaden, you understand already? Yeah? Wait. Okay, let's do this one last one. Then we call it end to this chapter, not a day yet. Okay, for the find the least value of a. Okay, so let's look at question 15. Okay, we want to find the least value of a for which the graph intersects the x-axis. Okay, so what do we want to find in this case? Okay, we're trying to bring the question first up. We are not trying to find that all. So we want to find the least value of a. Okay? Right? Then we are given some information. The question says for which the graph of this intersects the x-axis. Okay? So, did the question say how many intersections are there? No, right?
At least one.
At least one. Okay? So what when it doesn't give clarity over how many intersections are there, it actually implies having at least one x-intersection. Okay? So that means your discriminant must be more than or equals to 0. Right? So, therefore, to solve the question, we want to find the discriminant first. Okay? And what would be the B, what would be the A, and what would be the C? You want to try? You try this. What is the B value? Or the B that you identify from this function? 2? Is it just 2? 2k? Is it just 2k? Huh? Plus 2k? What is that? Negative 2k. Okay, so the coefficient of x is negative 2k square minus 4. And what is a in this case? 1, great. And c? K square minus 3 plus x. Yes. Okay. But we must be careful. There is a bracket. Is that correct? Actually? Most of us have x, right? Yes, have x. Okay. So we need to expand this first, right? Because there's x here, there's x here. Okay, so we cannot directly read out the discriminant yet. Okay? So then now, what is our A, B, and C? Maybe I write A, B, and C. A just now, we identified as 1. What's B now? Is it only negative 2k? Minus? I can't hear you. Minus 1. Okay, and then your C is k square minus 3. you can find out this rule. Okay, so our discriminant shouldn't have the variable inside it, shouldn't have the x. Okay? And now we have to expand this negative 2k minus 1 bracket square. How to expand this? A square minus 2ab plus b square. What will our expansion look like? Let me just call someone. Daryl, can you expand this one, please? What will you get? You read out and then I write. 4k square plus 4k plus 1. Okay, so this is the expansion that Daryl claims it becomes. Do we agree with this? Yes, you did. Yes. Oh, because actually from here there's minus 2k and it's minus 1. Okay, yes, yeah. Do you agree with this expansion? No? Anybody thinks otherwise? Yes, now? Negative 4k square or 4? Okay, 4k square minus 4k plus 1. Okay. So which one is correct? Which one is wrong? Okay. We show our pens. Everybody we show your face hand. Who agrees that the red one, the first one from the arrow is correct? Okay. Who agrees that the green one, A from how is correct? Okay. Right. I think maybe some of you are a little bit trying to process this first. Okay. Let's do this slowly one by one. Okay. To check. Why is it that I want to emphasize on this? Is because I know that many of you do a wrong expansion. Do a wrong expansion for this one. Okay. So if you want to use the identity, we must make sure you use it carefully. Okay. What is the A and what is the B? And which identity to use? Okay. Your negative 2k is actually the A. Alright? And then after that, the B is going to be 1. Okay? If you are using A minus B bracket square identity. Alright? Because we must segment out. This is A minus B is just a number. We don't take the sign with it. So in this identity, it expands out A square minus 2AB plus B square. Okay? So what that means is that A is negative 2k square minus 2 negative 2k and 1 plus 1 square. Right? Okay, so brackets are important. And this gives us 4k square plus 4k plus 1. So actually the arrow's one is correct. Okay? We accept this expansion?
Yes, it's just the meaning.
Right, Okay, so we must be very careful about that. In fact, okay, I would have seen it otherwise. Okay, I would have thought of this as negative 2k plus 1 square. I don't know how many of you think this way. To factorize out the negative side. Okay, which is actually the same as negative 1 square and 2k plus 1 square. And negative 1 square is actually just 1. So, this is the equivalent expansion of this. For which we know how, right? This one is simpler when one use identity. Alright? No? Okay? So we just got to be very algebraically careful when we do our steps. Alright? So long as you're very clear about what is correct, what is wrong, then you decline. Okay? So this is the correct step, red one. And then we continue, minus 4k squared, minus 4 times minus 3, that will be plus 12. Okay? And then I will continue here. Okay, I'll continue in purple. Okay, which simplifies to be 4k plus 13. Right? So just try outline segment out. Okay, so 4k plus 13, and we are given the information that discriminant is more than or equals to 0. So 4k plus 13 is more than or equals to 0. 4k more than or equals to negative 13. And k is more than or equals to negative 13 over 4, which is k more than negative 3 and 1/4. Okay, this is not what the question wants us to find, right? Question wants us to find least value, and what's the least value going to be? Okay, it will be negative 3 and 1/4. So make sure you answer the question. Any questions? Yeah. I'm not sure whether some of you can see clearly what is the coefficient of A, B, and C. As in the A and B and C. Maybe for some of you may want to do this. Okay? Just that you must remember this minus sign and all the brackets. Okay? Alright? Just wondering, what if I change the question? Okay? To say that it intersects the x-axis at 2 points. Okay? I tell you that you say discriminant must more than 0, right? Okay? So that means our inequality changes. But is it possible for us to find this value of k? Would there be an answer? No. Okay, so actually the question wouldn't be valid anymore. Okay, because I cannot find what is the next number that is more than negative 3 and 1/4. I cannot say it's just an increment of 0.1. Because you can also consider an increment of 0.001. Right? Or 0.00001. Alright? So actually, if they were to specify at 2 points, the question wouldn't be a valid question, we won't be able to answer it. Okay?